Hello, good day everyone. So we are on our week number 6 for logic design and switching. And for today's discussion, we're going to discuss Karnaugh Maps. So here's our learning outcome. So we're going to plot function in a Karnaugh map. We're going to obtain the minimum sum of products and product of sums for a function. And we are going to incorporate a don't care condition in obtaining the minimum SOP or sum of products or POS or product of sums, okay, form of the function. Okay, so what is Karnaugh mapping? So the map method, also called the Karnaugh map or Kmap, provides a simple way to simplify Boolean functions. It is a table or diagram made up of squares. So each square represents a minterm of the function that is to be simplified. Simplifying a function entails marking all squares that represent the minterm of the function with ones or zeros, and using patterns of adjacent marked minterms to arrive at simplified algebraic expression of the same function. And the number of adjacent squares combined must be in a power of 2. This means that when we combine adjacent square, it must be in the power of 2. So it could be 2 by 4 by 8 by 16, etc. And now, let's look at two-variable Kmap. So functions with two inputs, x and y, will produce a maximum of 4 minterms. So where did we get the how did we derive for the 4 minterms? Okay, so we have used the 2 raised to n formula. Here, we have the 2 raised to n formula, wherein n being the number of variables in the function. So on our example here, we have 2 variable, we have x and y. So x, okay, so take note how our variables are placed on our map. So if you can see here, we have here x with 2 value. So what are the value of x? We have 0 and 1. It is the same as y, wherein y has 2 values. Okay, we have 0 and 1. For our boxes, okay, so let's start with minterm 0. So minterm 0 is the intersection of x and y. So what is the value of minterm 0? X is equal to 0 and y is equal to 0. That is why we have here x prime, y prime. So this is the same as how we get our minterms in the truth table. Okay, as discussed from our previous discussion. Okay, so now let's go to minterm 1. So minterm 1 is the intersection of x is equal to 0, okay, and y is equal to 1. That's why we have x prime y. And for our minterm number 2, okay, or minterm 2, so that is the intersection of x and y, where x is equal to 1. So that's why we have x, and y is equal to 0. So we have here y prime. As for minterm 3, that is the intersection again of x and y, where x is equal to 1 and y is also equal to 1. So we have here x, y. And we have here figure number 2. We have plotted values for minterm 1 to be 1, minterm 2, 1, and minterm 3 to be 1. And if we are going to look at the Boolean expression on each minterm, minterm 1 is actually x prime y. Here, this one. So minterm 1 is x prime y. And we have, for minterm number 2, that is x y prime. And for minterm 3, that is x y. And again, for our grouping of adjacent squares, we are allowed to group in the power of 2. So it could be 2 or by 4 since we only have 4 squares. So we are only allowed to have group of 2 and group of 4. So on our example, so we have here 2 adjacent squares. Okay, so let's look at M1 and M3. So they are adjacent. And for M2 and M3, so they are also adjacent. So we have for two variable Kmap, let's say we don't have any group and we only have one square. So we can actually have an answer of the mean term, of one mean term, or that is two literals. Let's say our answer is group in two adjacent squares. So we have two adjacent square, meaning our answer will be equal to one literal. And let's say all of our boxes or four adjacent squares are 1, meaning, okay, so meaning that that is equal to 1. And let's look at this example. So this is the same example given from the previous slide. Okay, so using Boolean algebra, so we have, for example, for mean term number 2 and mean term number 3. Okay, so in mean term number 2, our expression is x, y prime, okay, plus mean term 3, which is x, y. Okay, so since both of the term, so x is common on both terms, so we factored it out, and we know that y prime plus y is actually equal to 1. And x and 1, or x times 1, that would be equal to x. That is the same if we are going to use Boolean algebra to simplify the pair for our pair mean term 1 and mean term 3. So mean term 1 is x prime y and mean term 3 is x y. So we have x prime y plus xy. Again, y is common on both terms, so we factored it out. Okay, and we know that x plus x prime is equal to 1. So that is why this is equal to y. That is when we use Boolean algebra to simplify these mean terms. But in Karnaugh Map, okay, so what we do is we are going to look for similarity. Okay, so again, if it is not similar, okay, so we are going to cancel it out. Okay, but if it's similar, we are going to get what is common on this group. So let us first look at mean term 2 and mean term 3. Okay, so we have mean term 2 and mean term 3. So first, let's look at the value of x. So what is the value of x on mean term 2? So we know that mean term 2 is xy prime. And the value of x in mean term 2 is x. Okay? How about mean term 3? So mean term 3, the value of x on mean term 3 is also 1. And the value of y is y. So again, looking at their expression, so again, mean term 2, x is equal to 1, y prime, so we have xy, and then for mean term 3, that is xy. So what is common? This one. So what is common to these two terms? So both of them are x, but they are different on their y. So we are going to cancel out y because they have different y, so what is left is x. So therefore, min term 2 and min term 3 is actually equal to x. Okay, so x. How about min term 1 and min term 3? So we have group min term 1 and min term 3. Again, if we are going to look at the value of x of min term 1, that is x prime. Right? So this is x prime. How about min term 3? So the value of min term 3, the value of x in min term 3 is x. So min term 1 and min term 3 have different value of x. The other one is x prime and the other one is x. Since they are different, so we are going to cancel it out. So what is common to them is both of them are y. So min term 1, okay, the value of y on min term 1 is y, and the value of y in min term 3 is y. Since they have since both of them are y, so the expression, okay, for this group is y. So summing up adjacent minterm, we can say that the value of f is x plus y. And as for three-variable Kmap, a function with three binary variables has 8 minterms. Our Kmap will also consist of 8 squares. However, the arrangement of minterms is different. We maintain that only one bit changes from any two adjacent squares, similar to gray code. And as for the result of grouping, so let's say we have one square with no group. Our answer will consist of 3 literals. And let's say our grouping, or we have grouped two adjacent square, meaning our answer will have 2 literals. And let's say we have grouped 4 adjacent squares, our answer will have or consist of 1 literal. And if we have grouped all the squares, or that is we have grouped 8 adjacent square, that is equal to 1. And take note of how our variables are arranged on our table of squares. So x, or the first variable, is placed below, and y, z, is placed above. And our x will have two values. We have 0 and 1. The same as x and y, which also have two values. That is, this is y. This is the value of y. And this will now be the value of z, the second value, which is the value of z. So that is 0, 0. Take note, 0, 0, 0, 1, 1, 1, and 1, 0. And again, for us to get, okay, or for us to plot our minterms, take note on how they were arranged. So our M0 will be placed here on this box. Okay, the intersection of x, y, z, which is 0, 0, 0. That's why we have here x prime, y prime, z prime. Okay, so followed by M1. So this is our M1. So the intersection wherein x is equal to 0, y is 0, and z is equal to 1. So that's why we have here x prime, y prime, z. So that's our M1. And take note of this. This is, we have to skip because our M2 is placed on this square. Okay, so you skip. And then M3 is placed here. Again, take note that M3 comes first, okay, before M2. As for M4, so it is here on this box. For M5, again, we have to skip. Our M6 is placed on this area. And then we have here M7. So 5, skip, that is 6. And then we have here M7. So take note of the arrangement of our minterms. Okay, so as for our example here, so let's say given the function of x, y, and z is equal to the summation of minterms 0, 2, 3, 4, and 6. So we are going to plot this one. So if we can see here, M0, so we are going to tag it with 1. So there. So this is M0. That's why we have 1 here. Okay, this is M2. We place 1. And then we have here M3. We have here M4. And we have here M6. And we are going to group them with the power of 2. So the priority will be, do we have 8 adjacent squares? None. Do we have 4? Yes. Okay, so this is allowed in grouping. So you can actually group, okay, in this manner, that this is allowed. This one, that is allowed. So we have group of 4. This. That is allowed, huh? Okay, so as if you are folding a paper wherein 2 ends meet. And another group is we have M3 and M2. This one. Okay, so this will be another group. So let's start, okay, with the first group, which has 4 adjacent squares. Again, we are going to look for similarity. Okay, if they have the same or similar value with x, y, or z. Okay, so first, okay, so let's look at the value of minterm 0. So what is the value of x for minterm 0? So the value of x for minterm 0 is x prime because x is equal to 0. But if you are going to look at M4, the value of x is equal to 1. So M0 is x prime, has a value of x prime, and M0 has a value of x. Since there is a change in value from x to x prime, meaning we are going to cancel x. Okay, so we are going to cancel x. Okay, now let's look at the value of y. So, what is the value of y for minterm 0? So, the value of y for minterm 0, if you're going to look at here, so y is y prime. But if you are going to look at M2 or minterm 2, the value of y is y. So, M0 is y prime. M2 or minterm 2 is y. So there is now a change, diba? So this is, they are different because this is y prime and the other one is y. So therefore, y will be cancelled out. But if we are going to look at the value of z, okay, so let's take note of the value of z of M0, M4, M2, and M6. Okay, so the value of z for M0 is z prime. The value of M4 for z is z prime also. And the value of M2 is also z prime. And the value of M6 is also z prime. So if we can see, okay, M0 is z prime, M4 is z prime, M2 is also z prime, M6 is also z prime. So z prime is common to this group. So therefore, we can say that this group is z prime. There. So that is z prime. And if we are going to look at the result, it states here that if you have 4 adjacent squares, you will have an answer of 1 literal. So since we have group 4 squares, 4 adjacent squares, okay, so our answer is z prime, which is 1 literal. Okay, next. Okay, so now let's look at M3 and M2. Let's look at M3 and M2. So what is the value of x for M1 and what is the value of, what is the value of x for M3 and what is the value of x for M2? So here, so the value of M3 for x is x prime and the value of M2, the value of x for M2 is also x prime. So both of them, di ba? So they have x prime is common on both M3 and M2. So take note of this. Okay, so we have here x prime. Ayan, because both of them have the same value of x, which is x prime. And now let's look at the value of y. Okay, so let's have the value of y. What is the value of y for M3? So this is y, the same, right? And M2 is also y. So both of them have the same value of y. So both of them have the same value of y. So we'll take note of that. So that is y. There. Okay? And if we are going to look at the value of z, for M2 and M3, so this one is z for M3 and M2 is z prime. Since there is a change, so they have different value of z, so z will be cancelled out. So therefore, so sometimes we may come across a mapping such as this figure. Okay, so it is best to inspect the diagram before grouping the ones. If not, we might make the mistake of including redundant terms. So the result of combining squares that are already covered by other combination. So for example, okay, so we are going to group, okay, so we're going to group these adjacent squares. So if we are going to group them and we include a redundant term, just like here, so we don't need to combine the mean terms M1 and M5. Because both are already covered by other combinations. So if we are going to include this combination, we will produce the expression x prime y prime plus y prime z plus x z. And if we are going to look at the consensus theorem, okay, so the product term y prime z is our consensus term, which can be eliminated by leaving as xy prime x z. So again, if it is already covered, there is no need for us to group these adjacent squares. And the proper way to do that is, okay, so we just group M0 and M1, and we group M5 or mean term 5 and mean term 7. There is no need to group M1 and as for 4-variable Kmap, the rules for simplifying 4-variable Boolean function using Kmap is the same as the rules discussed in the 2 and 3-variable Kmaps. We simply need to watch out for the arrangement of minterms. So we must also be aware of the number of literals that each product term has after combining adjacent squares. Okay, so again, let's say we have here one square and there is no adjacent square. So meaning we will have a 4 literals. Our result will be 4 literals. And for example, we have 2 adjacent square. Okay, so let's say we have 2 adjacent square. So our the result will have 3 literals. And let's say we have 4 adjacent square. The result will have 2 literals. And if we have 8 adjacent square, so there will be 1 literal. And if we have 16 adjacent square, that is equal to 1. And again, take note and watch out for the arrangement of minterms. So given 4 variables, let's say we have here wx and yz. So below is we have wx and above is we have yz. So wx has the following value. So the first value here, let's say we have here 0, 0. The first value would be for w and the second value will be for x. Okay, so we have 0, 0, 0, 1, 1, 1, and 1, 0. And for yz, the same. Okay, so the first value is for y and the second value is for z. And look out for the arrangement of minterms. So we have here minterm 0, minterm 1, and then it will jump. So minterm 2 is placed here. We have here minterm 3. We have here minterm 4, minterm 5 skipped. That is minterm 6. And we have here minterm 7. And watch out for minterm 8. So minterm 8 is located here. So this is minterm 8. Minterm 9 skipped. This is minterm 10 and minterm 11. As for minterm 12, so we have here minterm 12, minterm 13, minterm 15, so skip minterm 14, and we have here minterm 15. So we have prime implicants and essential prime implicants. So prime implicants, that is a product term obtained by combining the maximum possible number of adjacent squares. And we also have the essential prime implicant. So the prime implicant that has at least one square that is not covered by other prime implicants. Okay, so let's try this. Okay, so we are asked to simplify, okay, this function. So the function of w, x, y, and z is equal to the summation of minterm 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, and 14. So first of all, we have to plot first our minterms. So we have here minterm 1, minterm 0. We have here minterm 2. We have here, minterm 1, I'm sorry. So this is minterm 2. We have minterm 4, minterm 5. We have minterm 6. We have minterm 8. We have minterm 9. We have minterm 12, minterm 13, and we have minterm 14. So after we have plotted our minterms, now let's group them. So again, our priority would be the group of 16. Again, since we are grouping, di ba, in the power of 2, so 16 will be our priority. So if there is no group for 16, so the next priority will be group of 8, followed by group of 4, followed by group of 2, and we have here a single square. So looking at our Karnaugh map, do we have a group of 16? So we don't have. So next, we are going to look for a group of 8. Do we have a group of 8? Yes. Right? So we have here the group of 8. So we can group this one. Okay? So this is a group of 8. So do we have another group of 8 aside from this? None. right? So next, let's look at a group of 4. Okay, so can we find group of 4? Yes, right? So this is a group of 4. This one. Okay, and here. So that's a group of 4. And then do we have another group? Okay, so if we are going to first look at the group of 4, or group, I'm sorry, group of 8. Okay, so let's check this. Okay, so for group of 8, so that involves M0, minterm 0, minterm 1, minterm 4, minterm 5, minterm 12, minterm 13, minterm 8, and minterm 9. Again, let's find similar value for these 8 adjacent squares. Okay, so do they have the same value of W? Okay, W. So if we are going to look at M0 and M4, minterm 0 and minterm 4, they have the same value of W. But if you are going to compare M0 with M12, so M0 or minterm 0 has W. W is equal to 0. But if you're going to look at minterm 12, the value of W is what? 1. So there is now a different value of W for minterm 0 and minterm 12. So we are going to cancel out W. Okay, so same with X. Okay, so they have different value of X. Why? If you are going to look at M0, so the value of minterm 0, X is equal to 0. While if you are going to look at M12, the value of X is 1. So again, they have different value of X. Therefore, X will be cancelled out. Okay, now let's look at the value of Y. Okay, so M0 has a value. So let's look at this value. M0, okay, for minterm 1, Y is equal to what? 0. For M4, the same, Y is equal to 0. M12, the same, Y is equal to 0. And all the rest, no, we have minterm 1, minterm 5, minterm 13, and minterm 9. So if you are going to look at, all of them have the same value of Y, which is Y prime, or Y is equal to 0. And if we are going to look at value Z, so they have different value of Z. So for example, M0, the value of Z for M0 is 0. And the value of Z for M1 or minterm 1 is equal to 1. So there is now a different value in Z. Therefore, Z will be cancelled out. So therefore, the group of 8 is actually Y prime. Okay, so we have here Y prime. So we have Y prime. Okay, so let's look at, a group of 4 adjacent squares. This one. Okay, so we're going to look at M0, okay, M4, and then we have M2, and we have M6 or minterm 6. So do they have common value of W? So M0 is W prime, right? And for M4, the same, it's W prime. Same as M2 and M3. So both of them have, the value is W prime. How about X? So the value of X for minterm 0 is 0, while the value of X for minterm 4 is 1. So they have different value of X. Therefore, X will be cancelled out. And now let's look at the value of, let's look at the value of Y and Z. So the value of Y for minterm 0 is 0. But if we are going to look at the value of Y for minterm 2, that is 1. So they have different value of Y. So Y will be cancelled out. And let's look at the value of Z. So M0 and M4 has the same value, which is Z prime. Same as M2 and M6. Okay, M2 and M6, so they have the same value of Z, which is also Z prime. So we have here W prime, Z prime. And as for the last group, okay, so as for the last group, so we have here M4, this one, so we have M4. So we have M4, we have M6, this one, and then we have M14 and M12. Okay, so what is common to them? Okay, so let's see. Okay, so the value of W for M4 is equal to 0. But if we are going to look at M14 or M12, the value of W for M12 is equal to 1. So they have different value for W, so that will be cancelled out. Okay, so let's say we have X. Okay, so let's look at the value of X for M4, M6, M12, and M14. Okay, so for the value of X for M4 is 1. For M12, it's also 1. For M6, it's also 1. And for M14, it's also 1. So these four adjacent squares have the same value of X, which is X is equal to 1. Okay, as for Y, so the value of Y for M4, so the value of Y for M4 is 0. But if we are going to look at the value of Y for M6, that is Y is equal to 1. So they have different value of Y, so Y will be cancelled out. Okay, and then let's look at Z prime, or Z, I'm sorry. So do they have the same value of Z? So for M4 and M12, this one, so this is Z. So both of them have Z prime. And for M6 and M14, both of them also has a value. Okay, and as for the product of sum simplification, so this is our procedure. So first is you have to place 0 in the squares that are not included in the function. And combine the zeros into valid adjacent squares, much like combining the ones. So the simplified form gives the complemented function, and obtain the complement of f prime to give back the function of f in product of sum forms. And to simplify the Boolean function, okay, so let's say we have this problem. So we are asked to simplify the function a, b, c, d is equal to the summation of mean terms 0, min term 0, min term 1, min term 2, min term 5, min term 8, min term 9, and min term 10 into sum of products form and products of sum form. So first, we have to place ones in the squares corresponding to min terms of the function and place 0 in the remaining square. And combine the squares with ones to produce the simplified function in sum of product form. So let's say we have simplified it. Okay, our min term is already simplified. F is equal to B prime, D prime plus B prime, C prime plus. Okay, so given this Karnaugh map, that the function of A, B, C, and D is equal to the summation of min term 0, min term 1, min term 2, min term 5, min term 8, min term 9, and min term 10. So after we have plotted, okay, the ones, okay, so we are now going to plot zeros. Okay, we have plot zeros. So the same thing as we have grouped the ones in the min term, we are going to group zeros. And the same, we are going to find which is similar, and that will be our expression. So take a look of this example. So let's say we group M3, M7, M15, and M11. So we have here zeros. Okay, so if we are going to group this, let's look at the value of A. So the value of A for min-term 3 is 0. But if we are going to look at the value of A for min-term 15, that is equal to 1. Therefore, min-term 0, min-term 3 is different from min-term 15. I mean, the A of min-term 3 is different from min-term 15. So, A will be cancelled out. How about B? So, for min-term 3, the value of B is 0. But if we are going to look at min-term 15, the value of B is equal to 1. Again, B is different from min-term 3 and min-term 15. Therefore, B will be cancelled out. But if you are going to look at C and D, min-term 3, min-term 7, min-term 15, and min-term 11, they have the same value of C, which is equal to 1. As for D, it's the same. They have min-term 3, min-term 7, and min-term 15, and min-term 11. They also have the same value of D, which is equal to 1. So therefore, this group is equal to CD. There. Okay, and you are going to do that, okay, when you group other zeros. So once you have grouped the zeros, so we will have a result of AB plus BD prime plus CD. This one. Okay, so F prime, so that is F prime. Again, the result of grouping the zeros, or when we combine the squares with zeros to produce the simplified complement of the function, we are going to apply the De Morgan's theorem to obtain the product of sum form. So again, when we have grouped the zeros, so that is actually our F prime. Since we are going to do the De Morgan's theorem, okay, so we have here F prime. So we're going to get the complement, okay, both on the left equation and right equation. So for F, we're going to get the complement of F prime. So that will become F prime prime. And the prime will be cancelled out. Okay, and the same, we're going to get the De Morgan of this expression. So again, we're going to distribute, diba, the complement. So this becomes now A prime. And again, since the operator between A and B is an AND gate, so it will become now OR gate. And since, okay, the first term, the operator between these two terms is OR gate, so it will be replaced by an AND gate. Okay, so this one will become C prime plus D prime, and we have here B prime, and then D prime. Since this is D prime, prime, and prime will cancel out, so this will become D. So therefore, our F is equal to, okay, so A prime plus B prime, and C prime plus D prime, and B prime plus D. Okay, and that's all for our presentation. So you may now raise your hand if you have questions and use the mic. Or you may now use our chat box or type in your question to our chat box.